It was in 1999 when an astronomer named John Geises and his colleagues discovered something extraordinary. It's not a bird, it's not a plane, and neither is it a Superman. They are super-Earths. Yes, you heard it right, with an S. We're not just talking about one possible Earth-like structure here, but rather a lineup of candidates. Who could possibly win the crown that beholds a thriving life? Let's get to know more about what this exoplanet system entails. Introducing Trappist-1. Before it had the name Trappist-1, did you know that it was called 2-mass J23062928-050285? That sure had a lot of numbers to dictate. You might be wondering where they got such a strange name from. Using the acronym of 2-micron all-sky survey, they came up with 2-mass. Then, in May of 2016, researchers started utilizing Chile's Transiting Planets and Planetesimal Small Telescope, or in short, TRAPPIST, to observe the star. So what happened is that they renamed 2-mass into TRAPPIST-1 as a tribute to this telescope. And now that we know the origin of its name, what about the timeline of discoveries and its features? So to continue where we left off, let's expound the information from way back in 2016. Astronomers had revealed the discovery of 3 planets orbiting this cool dwarf star, and it was just 40 light-years away, meaning its distance is 378 trillion kilometers, or 235 trillion miles from Earth. This updated data was revealed using the Trappist telescope at ESO's La Silla Observatory. What's really cool about this is that these planets had similar structures to Earth and Venus. However, it was mostly their size and temperatures that intrigued scientists to know more about these exoplanets. Several studies from a team of astronomers were conducted. Michael Guillon of the University of Liège in Belgium was responsible for observing this star and its planets. With Guillon was a team of astronomers including Susan M. Lederer of NASA Johnson Space Center. In contrast to our Sun, this dwarf star had a much shorter distance from its planet. This means the planet's orbital distance is also shorter. So, unlike our Earth, which orbits our Sun for 365 days, the first 2 planets have roughly 1.51 days to 2.42 days, respectively, with the rest of the fleet orbiting their star mostly less than 20 days. Seems like we'll celebrate the new year real quick on this planet. Sounds like an everyday holiday, right? Kidding aside, Michael Guillon spoke on this phenomenon himself. According to him, with such short orbital periods, the planets are between 20 and 100 times closer to their star than the Earth to the Sun. The structure of this planetary system is much more similar in scale to the system of Jupiter's moons than to that of the solar system. So, to summarize, astronomers found out that the planets are in what we call the habitable zone. This kind of system structure is defined as having a certain distance from the star that would hypothetically be the correct temperature range for liquid water to exist. In this zone, the planet is far enough from the star that the water could remain liquid instead of gaseous, and close enough to the star that any available water would not remain frozen. Old times exist to remind us that we've come this far. Before we tackle the big news of the James Webb Space Telescope making its first glimpse of the Trappist-1, there was once a telescope that made a major contribution. This is the Hubble Space Telescope. It made the first spectroscopic measurements of the Trappist-1 on May 4, 2016.
The Hubble Space Telescope has taken the first steps toward characterizing the atmospheres of 2 of these planets.
One of its main objectives was to look at the atmospheres of these exoplanets. And before discussing the Hubble findings, we must first know the element they tried to inspect. It's important to know that hydrogen and helium play a vital role. These two elements judge whether a planet is habitable or not. If the amount of hydrogen and helium is below a certain amount, this increases the chances that it's habitable. Astronomers were astounded when they found out that the amount of helium and hydrogen on Trappist-1 is low enough to conclude that it may have a rocky structure like Earth. With this amount of information, there is still so much that has yet to be uncovered.
There are actually 7 Earth-sized planets orbiting the nearby Trappist-1 star about 40 light-years away.
As luck would have it, the universe gave us another discovery. There are actually 7 possible super-Earths. Sounds a lot more like Solar System 2.0. Time to get out of our own bubble. Let's welcome Trappist-1 and say hello. Solar System 2.0. If there are several planets that are dubbed Earth 2.0, then we could be at the peak of discovering a possible Solar System 2.0. On February 22, 2017, the world of our own little solar system intertwined with a possible twin. This day sparked the discovery of the largest batch of Earth-size habitable zone planets. Together with ground-based observatories, NASA's Spitzer Space Telescope verified these planets and discovered the other 5 in the system. This system has 7 rocky planets. What makes it even more exciting is that all of these have the potential to have liquid water on their surfaces, a fact that piques the interest of scientists to hunt for extraterrestrial life. When it comes to the names of these planets, you may be wondering if it's technical or rather hard to pronounce. Well, worry no more, since it's just pretty easy to understand. Trappist-1's planets are classified from B to H, with B being the nearest to the star and H being the farthest. So, with another milestone in February 2018, a closer study revealed more about Trappist-1. The 7 planets indicated that some might have significantly more water than the seas of Earth. It can be either as liquid water on some, atmospheric water vapor on others, or ice on the planets farthest from their star. NASA's Kepler Space Telescope also determined that Trappist-1H, which is the farthest planet, may be covered in ice. Aside from this, a scientist conducted a study proposing that Trappist-1 is older than our solar system. It ages from 5.4 to 9.8 billion years, approximately twice as old as our own solar system, which was formed 4.5 billion years ago. To get to know more of its features, feel free to pause this photo for comparison of the Trappist-1 and our planetary system. Now, in 2021, Professor Abel Mendez from the University of Puerto Rico at Arecibo calculated the Earth Similarity Index, ESI, of the Trappist-1 planets. This index is based on data such as mass, radius, and temperature, and is used to determine how similar a planet is to Earth. The closer the ESI is to 1, the more Earth-like the planet is. Interestingly, 2 of the Trappist-1 planets have extremely high ESI, with Trappist-1e having a score of 0.85 and Trappist-1d a whopping 0.91. This is just so exciting, isn't it? And with the launch of the James Webb Space Telescope, we can expect to learn even more about these planets. JWST First Glimpse. The James Webb Space Telescope, JWST, has studied the atmospheres of rocky exoplanets with enough precision to identify what they're made of.
I personally work on transmission spectroscopy, so when a star moves in front of its planet, it sort of filters the starlight through the gas in the atmosphere, and that tells you what's in the atmosphere.
JWST has the sensitivity to direct different atmospheric compositions, including carbon dioxide, methane, and water vapor. The telescope's capabilities also allow us to detect hazes that might be present in the atmosphere. At a conference on December 13, 2022, scientists shared initial data from their observations of Trappist-1G. It hasn't been officially published yet, but according to Bjorn Bennecke, an astronomer at the University of Montreal, the results show that Trappist-1G doesn't have a hydrogen-rich atmosphere. To give a clearer picture, larger gas and ice giants like Jupiter or Neptune tend to have hydrogen-rich atmospheres. This could mean that Trappist-1G could have a thinner, more terrestrial type of atmosphere, like that of Earth, Venus, or Mars. If so, that would be good for the prospects of possible life. In a poster presentation at the conference, the first look at the transmission spectrum of Trappist-1c was also reported, but it was found that the results were affected by the star's magnetic activity. This must be taken into account when interpreting transmission spectrum in the future. Despite the observations presented during the conference, astronomers have not yet specified the exact atmospheric composition that these planets may have. This is because the planets of Trappist-1 are considerably smaller and are far more difficult to analyze compared to larger exoplanets like WASP-39b. JWST, however, will be able to identify them in the upcoming months and years. If the preliminary results have shown us hints, then the next few years could be some of the most exciting times ever.
This is the beauty of James Webb. 15 seconds with James Webb is like years of research with other.
Aside from this, expect that we will not only have answers to our questions, but a souvenir as well. If our solar system has a legendary family portrait captured by Voyager 1, well, the same goes for Trappist-1. NASA's Goddard Space Flight Center astronomer Nicole Colon made the following remarks in December 2022. Within the next year, we'll have a family portrait. Within every journey of space discovery awaits a mystery. Continuously, we uncover tiny fractions of this universe that puzzle us. Now that we've discovered something about these batches of Earth-like structures, might as well add more to your list. We have more. Of course, this is the universe. It does not end and has countless possibilities. If you're interested, perhaps our video, Finding Earth 2.0 – Exoplanets Better Than Earth, could give you another gateway to adventure. In this wide galaxy, continue quenching your thirst for curiosity. Thanks for watching.